All right, let's do our first exercise here. So we're going to be starting with 5.55 and it's called Math Tutor, but I like to call this one Math Quiz. I think that's a little bit better. It says, write a program that displays a menu as shown in the sample run. You can enter either 1, 2, 3, or 4 for choosing addition, subtraction, multiplication, or division respectively. After a test is finished, a menu is redisplayed. You may choose another test or enter 5 to exit the system. Each test generates two random single digit integers to form a question for addition, subtraction, multiplication, or division. For a subtraction question, such as number 1 minus number 1 is greater than or equal to number 2. For a division question, such as number 1 divided by number 2 is not 0. And then they were nice enough to give us a sample run here. So here we got the main menu displayed. The user enters a choice, in this case 1, and it gives them a addition question because 1 is tied to addition, and they got it right. Thank God. I don't think anyone will get this wrong, and they got correct. The next run, they entered addition again, and they somehow know how to do 1 plus 7, but not 0 plus 4. Ended up hitting 5, which was obviously wrong, and it tells them what the correct answer is. So basically, it seems like this program is going through a loop of some sorts where it would ask the person a question and they would pick the operation that they want to be quizzed on, and then it just gives them the question. It's actually fairly simple, but there was a lot of wording here, and I think the best way to tackle this, and this is where we're going to start solving the problem, so pay attention. I think the best way to tackle this problem is to go like line by line inside of the prompt here and just kind of, see what we can do by choosing each and every sentence one by one. So let's just read this again. It says, write a program that displays a menu as shown in the sample run. Okay, let's stop right there. Write a program that displays a menu as shown in the sample run. Well, what's the sample run look like? We know we have main menu, we have 1 addition, 2 subtraction, 3 multiplication, 4 division, and 5 exit. That is the menu that we're displaying. So just right off the bat there, I mean, we can pretty much do that, right? I mean, we have the necessities, we have the knowledge to be able to print out words. So let's just go into our editor here and let's set up our main function. So we'll do include IOStream. We'll just use namespace std for now. And we set up our main function. So remember, our goal right now is to simply just get out the main menu that is shown here. Now I have this in my second monitor, so I'm just literally just going to be following along with what is shown from main menu all the way down to exit. So we know we're going to need a bunch of cout statements. Let's see here. I'll just bring it here for visual sake. We need 1, 2, 3, 4, 5, 6 cout statements. So we'll just do cout and we'll type in main menu for now. Copy paste that. Cout main menu. And we could do a new line character as well, because we need that. So we're going to type out main menu followed by addition, subtraction, multiplication. That's 6 lines of words. 2, 3, 4, 5, 6. So, okay. So for here, we're going to put 1 colon addition. 2 colon subtraction. 3 for multiplication. 4 for division. And then we have 5 for exiting. All right, let's run this code and let's see if we printed out the menu correctly at least. All right, so that looks about right. We see we have our console here and we have the problem. So that's already one part of this program done, right? And you see why it helps to just go line by line. It becomes a lot easier. I want you to think of these exercises as kind of like, instead of just one big programming exercise, think of it as like little fractions of programming exercises that kind of add up. So let's go over to the next sentence. Now it's saying, hey, you can enter 1, 2, 3, or 4 for choosing addition, subtraction, multiplication, or a division test. So we know we need some user input because it's asking us to let people enter in a number. So we know we need, hold on, let me bring up my notepad here. So we know we need user input. And let's bring up the font here too. Maybe a little bit bigger, like 36. Okay, so we know we need user input. We're choosing 1, 2, 3, or 4. And this is like good thing to do. Just practice like taking down notes for like what you need. It doesn't have to be like some crazy like flowchart stuff, but just kind of like jot down like, you know, what you need. That way you have a little reference for it later. And it also just helps you to visualize and understand the program. So user input 1, 2, 3, or 4. Each number corresponds to giving out a test. Okay. So that's basically what this line is asking us to do. It says it wants us to enter 1 through 4 for addition, blah, 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 and have that user input decide which test is given. So we can do that. So we know we need user input, and we need each number to correspond to a given test. In this case, addition, subtraction, multiplication, or division. That sounds like if statements, right? That sounds like, you know, if a user does one thing, then do another thing. So we might need if statements for this particular program. In that case, whenever we have user input, we also want to store that in the variable. In this case, an integer variable because it's 1 through 4. So we'll do int user input. We'll just store that in there. And then we'll have it set so that the user has to put in user input. Pretty nice variable name. So let's just run this again, because one thing I like to do is just take everything a step at a time and just, you know, run the code every time I make a little change just to see if it's working correctly. So main menu, addition, subtraction, multiplication, division, exit, and then they have a little space for here for us to make a choice. So we'll just do 5. And you know what? Let's put some prompts here as well. We'll do cout, enter a choice. And then, yeah. So we'll do enter a choice and then cout. Let's just run it real quickly. Enter a choice. 1. Okay. Now let's go back to our notepad here. So it says that we now have user input and they can input 1 through 4 whenever they like. But now we have to have it so that each number corresponds to giving out a test. So not only do we have to take user input, but we also have to evaluate that. And based on that input, we have to execute a block of code. That sounds like if statements. So let's go back and let's start off our if statement. And let's focus on, like I said, one thing at a time. So let's just focus on getting addition running here. We want to make it so that when the user types in 4, that it runs the addition function. Or let's speak in code terms. If user input is equal to 1, did I say 4 last time? I meant 1. If user input is equal to 1, then we will do the addition question. So let's start off. Let's do if. In our condition statement, we type in user input, double equal sign, remember, equal to 1. Then we will now, in this block of code, we have to prompt the user to do some addition. So let's go back to our problem here and let's just see how it's displayed. So it just asks what is and then one number plus another number. Now also remember, it has to be a single digit number. So let's just keep that in mind. So I know there's like a question about random numbers and stuff like that, but let's focus on getting the main functionality done first. Now, what is the main functionality? The main functionality of this program is just making sure that when someone presses 1, they get addition. When someone presses 2, they get subtraction. When they press 3, the multiplication, and so on and so forth. Let's not even mess with the random numbers for now. Let's just see if we can get that running, and then we'll plug in the random numbers. So we want to get addition going here, right? So for now, instead of random numbers, let's just have a set addition question just to make sure that the thing works. So if user inputs 1, then we'll cout what is 1 plus 2, just as a message. And now, obviously, we want them to answer the question. So we're going to need some more user input. Give me a second. I want to format this a little bit. So we'll cin, and let's create an integer variable here called answer. Just so we could store the user input. So what is 1 plus 2? Cin answer. And then we want to check if they're correct, right? Because that's what the problem says. It says here, tell the person whether or not they're wrong or not. So obviously the answer to this is 3, and it will always be 3 because this is a string and we're not dealing with the random numbers yet. So we'll see answer, and then we'll have another if statement because we want to evaluate the answer now. So if answer is equal to 3, then we will tell them you are correct. And of course, if they are wrong, then we just tell them, hey, you're wrong. It's actually 3. Okay. So let's go over what we did for a second. We have an outer if statement that basically says, hey, if the user enters 1, do all of this. Well, what is all this? Addition. Okay, makes sense, right? Because 1 is for addition. And then inside, we have a variable called answer that is stored within after the user inputs answer. We have a question here that's asking 1 plus 2. So we know that the answer is going to be evaluated. So if the answer equals 3, then you are correct. If else, then you are wrong, obviously. So let's just run this code and let's see what happens. Missing semicolon. All right. Enter a choice. 1. What is 1 plus 2? 3. You are correct. Let's check if it's wrong. So we're going to get this wrong on purpose. Enter a choice. 1. What is 1 plus 2? 5. You are wrong. The answer is 3. Okay, cool. So this is what I was talking about when I said, hey, let's just get the base functionality right before we even think about random numbers and all that doohickey stuff. It's easier to kind of break these problems down in a way where you can just like see and visualize how things are going to go. And then you can start adding on the more complex stuff as you go. Because if this was just a question, this would be easy, right? Well, it makes no difference if she just adds, okay, now do random numbers. Okay, now do only double digit integers. Like, it sounds like a lot when you try to take it all in, but if you take it piece by piece, it becomes easier and easier. So we have half the problem done, at least from looking from this prompt standpoint, right? We have a program that displays the menu in the sample run. We have it so that the user can enter 1, 2, 3, 4, 4 for just addition right now, but you'll see in a second why we basically already have the rest. Now it says after a test is finished, the menu is displayed. Okay. Before we even think about doing this, let's get our subtraction, multiplication, and division going first. Because the last part about displaying the menu is just a matter of throwing this all under a do while loop. So we have here, basically this all governs the addition stuff, right? If the user equals 1, if the user input equals 1, we're in the world of addition. But if we want it set so that if they enter 2, if they enter 3, if they enter 4, they go into the world of subtraction, multiplication, and division respectively. So what I'm thinking is we use another if statement. Because now we have it, we can just have it set so that when user enter 2, you'll see, oh, okay, now what's 1 minus 2? Actually, let's change this to 2 minus 2. And if the answer is 0, you are correct. Else, you are wrong. The answer is 0. You see how, what took us about 5 minutes to get this going? It only took us 3 seconds to get this going by changing a couple stuff. That's the benefit of being able to reuse code. But as you can see here, if we keep doing this for 2 more times, our code's going to get real messy and just kind of janky. And we actually have ways to deal with this. we're going to use functions and switches. But let's just run this so you guys get an idea of what's happening here. So we know that addition works, but let's run it again just to be sure. Enter a choice. I want to do addition. I'm feeling daring today. What's 1 plus 2? 3. You are correct. All right, let's run this again and let's do subtraction. Enter a choice. 2 for subtraction. Now we have what's 2 minus 2. That's a little bit harder, but I think it's 0. You are correct. Nice. Okay. So going back to what I said about how our code can get messy, we're going to use functions for each respective operation. So we're going to need 4 functions. And if you call back to functions, you can define them up top and then you can declare them up top and then define them on the bottom. So we'll have 2 functions. We'll call this one void add. We'll call the subtraction function void sub. We'll call the multiplication one multi. And then we'll call the division one div. Actually, that's a keyword if I remember correctly. So we'll call it divvy. All right, and then we'll define them down here. So we'll do void add curly brackets. And then we don't gotta do much. We just gotta change all this and stick it in here. Actually, we don't need the if statement, the outer if statement. What we're gonna do is we're gonna copy the contents of the outer if statement here, right? We're gonna stick it in here and fix our spacing. And then instead of if user input equal 1, do all that crazy stuff. If user input 1, call the add function. Now this will do the exact same thing, right? Because it's basically saying if user is equal to 1, user input equal to 1, then we know they want addition. So we're calling the addition function that we just created. And inside the addition function, okay, what's going on in the addition function? Oh, basically the same stuff that we had before. So let's run this. Enter a choice. 1. What's 1 plus 2? 3. Works like a charm. Now you see how like doing this, if user input is equal to 1, add. If user input is equal to 2, then we'll call sub. That is a lot cleaner and a lot more efficient than simply just doing if 1, do all this. If 2, do all this. If 3, do all this. Like it's unnecessary and it's not good code and it's not good practice. So let's just set up our subtraction function as well. Let's do that. Since we already did the code for it, why not? So we'll do void sub, parentheses, followed by a set of curly braces to define our subtraction function. And then the same thing, right? Grab everything inside of the if, copy, paste, fix our spacing. Gotta get this one going here. Whoops. And yeah, this should do the same exact thing. If we just call this the subtraction instead of all this stuff, we don't need all this messy stuff. We'll do sub followed by a semicolon to call our function. And let's run this. Should be the same thing. What's 2 plus 2? 0. Now, whenever you find yourself using multiple if statements, like we can tell we're going to be using 1, 2, 3, 4 if statements. That's a lot of if statements. Whenever you find yourself in a situation like that, it's actually better to use switch cases. Now, switch cases are basically just if statements, but they're condensed so that you're not doing if else, if else, if else, but instead you're just taking a value and you're evaluating it through tests. So you're checking if user input is equal to 1, is it equal to 2, is it equal to 3, is it equal to 4, or is it equal to 5? That's a lot easier than saying if else, if else, if else, and you'll see in a second. So let's just take away all of this. We still need their user input though. User input. And then the way we use switches is we basically just say switch followed by the expression. In this case, we're evaluating user input. That's the thing that we want to evaluate. And then inside here where it says constant expression, that is where we're going to put our 1, 2, 3, and 4. So it's basically saying in the case that the user enters 1, do this code. And what do we want to happen when they enter 1? We want to call the add function. It's just like the if statement. This is basically saying if 1, add, and then break out. So we're going to add a couple more cases. So let's do case 2. Actually, you know what? It might be better if I just type this. Case 2, subtract. And we have subtract and addition for now. So let's just do it like that. And the good thing about switch cases is it's right now, you see this default break here. It's basically saying, hey, if the user enters anything other than 1 and 2 at this point, then just break out of this the if statement, or switch case in this rather. So let's see here. Enter a choice. We got 1, 2. So let's just do 2. What is 2 minus 2? 0. You are correct. And the reason why we want this default case here is because let's say before, whenever we entered 5, nothing would happen. But now when we enter 5, we actually exit out. Or any number for that matter. But that's fine too. If the user enters anything other than 1 through 5, that's on them. Okay, so we basically have it set up so that we can do any operation, right? Even though we already have addition and subtraction, obviously just changing these to multiplication and division is a matter of changing up the symbols, right? If this was multiplication, for example, if we were making a multiplication function, we would change this to an asterisk, we would change the value of this, we would change the string for this, and then yeah, we would have multiplication. So instead of focusing on that mundane task, let's tackle the giant of adding in 2 random single digit numbers. That I think is the part that trips a lot of people up. So let's do that now, and then we start adding in our multiplication and division functions. So whenever you hear the word random, or whenever you're doing a programming prompt where it's like, I need a random this, or you know, you want to leave something up to chance, a great library to import is ctime. So we'll come up to the top of a program, right under IO stream, we'll import ctime. And this allows us to generate random numbers. So at the top of our function here, let's add in, basically this line of code takes advantage of the computer's internal clock to generate randomness or simulate randomness. You don't need to know exactly what it means down to a technical level. Just know that you need this line of code to make random numbers work. So at the top of our addition function, we're going to type in srand followed by parentheses, time, null. And don't even worry about what this means now. Like I said, just remember this is needed in order to generate our random numbers. So we want the question that asks, what is random number plus random number, right? So we know we can't be using strings anymore, right? Because no matter what, this will always be 1 plus 2. So let's just get rid of this line for now. So we need 2 random numbers, and these numbers need to be modifiable. So obviously that's telling me, okay, we need integers. So we'll do int rand num1, and then we'll declare another integer, int rand num2. And now instead of asking directly what's 1 plus 2, we'll ask the user, cout, what is space rand num1, and this is addition, right? So we'll do plus rand num2. I did not forget that over here, this little arrow. And the reason why we're doing this like plus in quotation marks is because we're not actually trying to add these numbers just yet. We're just asking the person, hey, what's this number plus this number? But if we put it so that it's like, oh, what's rand number plus rand number, what's gonna happen is if this was 1 and this was 2, the question would be, what is 3? Because it thinks it's trying to add, but we don't want adding. We just want to print out the plus sign between the two numbers so that we can actually get a question and not just straight up give them the answer. And let's just throw in a question mark, because why not? Okay, so see out, what is random 1 plus random 2? So we have two random numbers, or rather we just have two integer values with no, we have two integers with no value in it right now. So we want to assign it a value and we want to assign it a random value. And thanks to our sran time null as well as c time up here, we can do that. And the way you do that is by setting this equal to rand with parentheses here, and we set this equal to rand with parentheses here. So instead of giving the integers like a set value, we set it to a rand, which will call in just a random number. And let's see if this works. Enter a choice, addition. Whoa. Well, that's definitely random. I'm not going to do that. But remember when we created our function for the first time? Going back to our code, we got a little cheat sheet here. We had it set so if the answer is 3, you are correct. So we're going to put 3 here, and let's just get this obviously wrong answer correct. So a couple things. One, our random numbers were not single digit. In fact, they were 4 digit. Also, the person can answer this incorrectly and still get it correct. So we have to change our answer condition, and we also have to limit this so that it only prints out numbers 0 through 9, because those are the only single digit numbers. So let's focus on getting single digit numbers first, because that's a little bit easier, if you can believe that. When it comes to this random function, whenever you want to set an upper limit to this, you basically just follow this up with modulus. And in this case, our upper limit is 9 because 0 through 9 are the only single digit numbers. So we just add 9 right after. And then for this one, we do the same thing because this has to be single digit as well. And now basically what this is saying is there's an integer called a random number, and we're setting that equal to a random number between 0 and 9 because this is our upper limit. Same with this one, integer with a that's called random number 2. We're setting that to a number between 0 and 9 because this right here is our max function. Our max number. Now let's go down here. So currently as it stands, even though it's going to generate random numbers, we still have to check if it's actually the correct answer, not just 3, because we're no longer asking what's 1 plus 2. We're asking some random numbers. So we have to check if the answer that the user inputs, is that going to be equal to the actual value between random num1 plus random num2. How do we do that? Well, we go into our condition statement here, and instead of setting this equal to 3, we just literally add random1 and random2. Just like that. So now we're checking, instead of checking if the answer is equal to 3, we're checking if the answer is equal to the value that you would get if you added these two numbers together. And we'll see out you're correct and see out you're wrong. Well, we got to change this as well. The answer is, instead of saying 3, we will say the answer is random1 literally plus random2. Remember how I said before that we wanted to make the distinction between the string plus and the actual operator plus? Because the actual operator plus will return the answer, but the string plus will actually ask the question. So let's see, do I have any semicolons I need to add? Nope, we're good to go. Let's see if this works. All right, it's your choice. Let's do addition. What's 6 plus 7? Nice. Those are random numbers. I don't remember declaring those anywhere. 6 plus 7 is 13. You are correct. Let's get it wrong this time. Enter a choice, 1 for addition. What's 1 plus 3? 100. You are wrong. The answer is 4. All right. So as you can see, we're pretty much like a quarter of the way done. But the main thing that I love about functions is now that we have our addition, we basically have subtraction, because it's just a matter of changing the operations, is it not? So that's why functions are really good for this lab. So let's just go in here and let's just paste in the same thing that we did for addition. Fix our indentation here as well. That's fine. So instead of, well, now that we're in for here, we were in the world of addition. Let's go into the world of subtraction. So basically, anywhere where I see a plus sign, bleh, I'm changing that to subtraction. So minus there, minus here, and minus here. And that's pretty much it. Now we have subtraction. Let's keep it going. Let's copy this entire thing. And instead, we're going to use multi for multiplication. Now we're in the world of multiplication. Everywhere I see a minus sign, I'm going to put a subtraction. I mean, asterisk for multiplication. And it's no different for division. At this point, a toddler can do this. That's the good thing about functions. It makes everyone's life easier. It makes the reader's lives easier. And it makes your life easier. So everywhere we see a multiplication sign, we're going to put a division sign. Because now we're in the world of division. You see what just happened there? We basically chopped this problem down into one small piece. And we benefited by making functions that allowed us to get the other operations running in no time. So here we have an addition function. This takes a random number 1, a random number 2, says, hey, what's random 1 plus random 2? Answer. If it's correct, you are correct. If else, you're wrong. Same thing. Subtraction. If you're right, you're right. If you're wrong, you're wrong. Multiplication. If you're right, you're right. You're wrong, you're wrong. Blah, blah, blah. Let's go back to our main function here. And so right now we only have 2 cases in our switch statement. But now that we have our all functions up and running, what we want to do is add those. So let's do, here we'll do case 3. And this is basically saying if in the case that the user enters 3, do this. In the case of the user enters 3, we want to do multiplication. So let's call our multi function. That's what I did. I called it multi, right? Yeah. And in the case that the user enters 4, we want to call our division function. So we call that divvy, right? Yeah. And default basically means any number that isn't 1, 2, 3, or 4, just break. And the reason why we're not putting case 5 is because we don't care what the user inputs. If it's 5, it's going to break. If it's 6, it's going to break. It doesn't matter. They're going to break regardless. But we want to make it so that as long as if they pick 1, 2, 3, or 4, they will get a question. So let's run this. Let's see what happens. So we did addition and subtraction. Let's try our multiplication. Let's see if my brain is cooking. What's 4 times 3? That is 12. You are correct. What is 5 divided by 3? That's actually unexpected. I didn't expect them to give me a division question here. Let's do 1 though. Okay, so what's happening here? I forgot to break out of the case. That's my bad. Yeah, make sure you add breaks because that's not the question. The prompt isn't asking us to, go through all of them. They just want you to go through 1 after hitting it. So that's why it went straight into division. Because what happened was it incremented our value. No, it didn't do that, but instead it just went down to the next case. But we don't want that. We want to break out. So let's run. Let's do that again. This time we'll do multiplication. 8 times 8, 64. You're correct. I'm on a roll today. There we go. So yeah, make sure you add breaks unless you want to go through every single case, but we don't want to do that. So let's just see if we covered all of our bases here. So it says, write a program that displays the menu shown in the sample run. We did that. You can enter 1, 2, 3, 4, 4 for blah, 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 blah. We did that. We have our functions. After a test is finished, the menu is redisplayed. Okay, so we don't have that. So whenever the prompt is asking you, like after your code is ran, redisplay the message, or like, loops or anything like that, you need to be thinking in the world of loops. Now, there's only 2 loops in C++. There's a while loop and there's a do while loop. For this situation, we want to keep on doing the execution unless the user enters 5, right? So that sounds like a do while loop situation. And do while loops are super easy. We just go into our main function below where we declare the data types. We'll just say do, and then we'll just throw all of this stuff inside of here. Let's just get my spacing together. So what we're going to say is do all of this while user input is not equal to 5. Now, why do we say not equal to 5? Because one thing I like to do with do while loops is whenever I'm confused about what a do while loop is doing, do while, whenever I'm confused about what a do while loop is doing, I just like to read it backwards. So this says, while the user input is not equal to 5, do all of this. And that starts to make a lot more sense, right? Because we want to make it so that that the user can keep on going to this main menu until they exit. So let's just run this code. Main menu, addition, subtraction, blah, blah, blah. So let's just go through like what's going on, right? In the data fields right now. So right now we're on line 23 where it says user input after it prompted me to enter a choice. And whatever we put in is going to be stored in the user input variable, right? So it's basically saying, hey, as long as whatever you type isn't 5, we're going to keep doing this over and over again. Okay, so let's type 6. Oh, it prompted me again. 6, 7, 8, 9, 10, 6. You know? So you see what's going on here? It's basically taking us in an endless loop, and it won't break us out unless it's not equal to 5. So if we enter 5, what's going to happen is we're going to go through all of the motions of the do loop, and it's going to say, wait a minute, hey, user input is equal to 5, so stop this. Like, this is our condition right here. So when we hit enter down here in our terminal, user input will be equal to 5, and this condition is no longer met, so we're breaking out of this loop. And since that's the end of our main function, there's nothing left to do, so we exit. So let's run this again, and let's just show you guys a regular test. So 1, 3 plus 1, 4. Cool. And even after that, we're back at the main menu, right? Because as it stands right now, I mean, we did addition, right? So right now, our user input is not equal to 5. So we keep doing the stuff, right? It's not equal to 5, it's equal to 1. So we're going to keep staying in this do loop. But now we're going to set it equal to 5 and get out. So that's how we exit. But also, I need to add a new line to you are correct, because right now, you guys see right here, right? It's all printing that on one line. So let's add a new line character to the you are correct message. You are correct, you are correct, you are correct. All right, let's just run that one more time to see how the formatting looks. Enter choice, 1, 8 plus 6. Man, they're hitting us with the hard ones, huh? 15. You are wrong, the answer is 14. Also, yeah, I gotta do a new line character here. Oof. Almost messed up. I'm glad I picked up on that. It's not a new line character there, it's a new line character after the numbers. Or we can do inline, whichever works for you. This is all part of the process, just running it over and over again and just fixing it piece by piece. It takes a very, very skilled coder to like get everything in one fell swoop, and you should never really expect that, even after you have a lot of practice under your belt. You should always just take each thing piece by piece. Rome wasn't built in a day, so your code shouldn't be built in 2 minutes. Let's enter 5 to break out and rerun this. And we should have good formatting now. Enter a choice, 1 for addition, 5 plus 2, that is 7. You are correct, and it displays the main menu again. Let's get a question wrong this time. 7 plus 1 is 9. You are wrong. The answer is 8. Okay, cool. So it seems like we covered all of our bases, but I think there is one last condition that we have to meet. So it says each test generates 2 random single-digit numbers to form a question for addition, subtraction, multiplication, division. Okay, cool. We did that. Now it says for a subtraction, such as number 1 minus number 2, number 1 is greater than or equal to number 2. Okay. So it's basically saying that no matter what subtraction question you get, have it set so that every time number 1 is always greater than or equal to number 2. So basically they're saying they don't want you to answer any negatives. Basically just have it rigged up so that you will always get a subtraction question where number 1 is greater than number 2. Okay, we can definitely do that. So let's look into our subtraction function here. And let's just see how our numbers are declared and how they're defined. We're grabbing a random number from 1 to 9. So we want to set it so that every time number 2 is randomly generated, and in the event that is randomly generated and it's greater than random number 1, we should probably just redo the generation. So let's see here. Whenever we're checking the condition of something, we always want to use if statements or switch cases. But in this case, we're checking one thing. So let's just throw in an if statement for simplicity's sake. So we'll do if random number 2 is greater than random number 1, we want to assign it a new value. So we'll say random 2 is equal to rand from 0 to 9. And that basically sets it so that as long as rand 2 is greater than rand 1, we're going to keep on doing this generation until this condition here is no longer met. So this basically sets it so that before we even ask the question, behind the scenes, what's happening is we're trying to pick out a random number 2 so that it's not greater than random number 1. So let's run this and let's do multiple subtraction questions to see if we can get a situation where, what's going on here? Do I have to stop it? Did I forget to stop it? That's my bad. So we're going to keep on doing subtraction to see if we can get a situation where random num 2 is greater than random num 1. We shouldn't, but let's just see. 2 minus 4. All right, that's literally the first situation. What's happening here? Let's go to subtraction. 1 minus 1 is 0. 2 minus 0 is 2. This is 4. 4 minus 0 is 4. I'm trying to get 4 minus 0 is 8. 6 minus 4 is 2. Literally the first one was 2 minus 4. So there's a chance. We just have to keep on running it. But why? Oh, you know what it is? Let's keep going though. Man, it's really hard actually. I'm gonna cut to when I get a question. Oh, okay. I got one. So 0 minus 5. So we didn't future proof our code. I think instead of an if statement, we need a do while loop. So we'll do random number generation. Okay, this is getting messy. Let's delete all this. We'll do the random number generation of number 2 while random 2 is greater than random 1. So remember what I said about do while loops and reading it backwards kind of helps. So basically, first we have 2 variables, right? Random is set to a random number, rand2 is set to a random number, and then we go into this do while loop. Now it's saying, hey, while random number 2 is greater than random number 2, do the regeneration of random number 2. And it's going to keep on doing it over and over and over again until our random number 2 is no longer greater than random number 1. So we were close. We don't need if statements, but we did need a do while loop. So let's stop this code. And we should never get a situation where number 1 is less than number 2. Let's see. That's 8 minus 8. That's 8 minus 8. That's 5 minus 1. A lot of 8 minus 8s. But we're never getting a situation where, you know, I mean, you can keep trying all you want. You can copy paste this code. I'll give you all the money in my wallet if you can show me the source code and show me that the number 1 is less than number 2. It'll never happen, because so long as random number 2 is greater than random number 1, we're gonna be in that loop of just regenerating. So even if random number is 0, then this will be 0, because it's gonna keep on generating random numbers until we hit 0. So let's stop this code. We know that works. And there's one last condition. So now it says, for division questions such as number 1 divided by number 2 is not 0. Okay, that makes sense, because we know in division, if we try to do division by 0, in this case, let's say 1 divided by 0, we know that is undefined. It's impossible to divide by 0. That makes sense. That's not even them being picky. That is just simple law. So we have to go into our division here. And let's say, okay, so random number 2, right? Whenever we generate a random number, we're setting this so that our upper limit is 9. So it is 0 to 9, right? It's actually, there's actually a very easy way to do this. So there's a chance that this can be 0, right? But what if we just add 1? Like, just increment this by 1 after it's generated, right? So that if this, let's say, like, okay, we did the random generation, right? Rand number 2 is assigned a value of 0. Then we're gonna increment random number by 1, right? Now it's 1, and there's nothing there's nothing anyone can do about that, because so long as line 118 exists, it'll always have the value of 1. That's the least amount it can have. But we also have to be careful after we do that, because we also just kind of increased our upper limit, because in the case that random number 2 is set to 9, it will now be 10. And remember, the question said no double digit numbers. That's an easy fix as well. We'll set this equal to 8. So now in the case of 8, it'll get 9. So 9 is still possible. And in the case of 0, it'll get 1. So 0 is impossible. And that was a very funny way of just doing it. You literally just add this random number and increment it by 1 at this line here, and you're good to go. Just make sure that the upper limit is set to 8 so that you don't go over this single digit limit that they placed upon us. And let's run this. Let's do some division. Let's see if we can't get 0. So we'll enter a choice. In this case 4. 8 divided by 4. I'm pretty good at division, so 2. That's correct. Let's do a division again. Let's just keep running it. I just want to see if we can get 0. And yeah, it looks like 0 is impossible for random number 2. So I think we covered all of our bases, right? We have a program that displays the menu shown in the sample run. We can enter 1, 2, 3, or 4 for choosing addition, subtraction, and multiplication or division. After the test is finished, the menu is redisplayed. We can choose 5 to exit the system. Each test generates 2 random single-digit numbers to form a question for addition, and these 2 we already did. So yeah, basically this is the lesson that teaches you about loops and functions. You want to be able to use functions in situations where you know you're going to reuse code, and you want to use switch cases in situations where you know you're going to use a lot of if statements. And of course, whenever they say, hey, redisplay the menu, you want to use while loops. And if you're trying to do something until a condition is met, always remember to use do while loops. And that is this exercise complete. I will post this code below in the description or the comments, and see y'all later.